A research excitation flight system was recently flight tested at NASA's Dryden Flight Research Facility. A NASA F-16XL aircraft served as a test bed. This exciter is unique because it is a self-contained, lightweight excitation system which can easily be strapped onto a variety of aircraft. It is intended to be used in flight flutter testing to help improve data quality and flight test efficiency. The system consists of a fixed vane with a rotating slotted cylinder at the trailing edge. The slotted cylinder rotates and the flow is alternately deflected upward and downward. This results in a periodic lift force which is imparted to the aircraft at twice the cylinder's rotational frequency. The exciter vane is controlled by the pilot in the back seat of the F-16XL aircraft, who sets the parameters for the test. Data is telemetered to the spectral analysis facility where it is monitored in real time. Here, response from the wingtips are monitored to find frequency and damping trends as functions of Mach number and dynamic pressure. The wing can be seen responding to the exciter vane's input, sweeping from 5 to 35 Hz. Data is analyzed in the computer, showing the aircraft's natural frequencies. Test points were taken between Mach 0.6 and Mach 1.7 at an altitude of 30,000 feet. The variables in the different frequency sweeps were linear or logarithmic sweeps, varying time length, varying force amplitude, and dwelling on a certain frequency. This exciter system has shown it can provide high-quality data and improve flight test efficiency with minimal interface to aircraft systems. Future testing will continue to provide insight into using this system as a safer, more effective flight flutter testing system for today's flight research.
Carrying up to 16 500-pound bombs cleaned up, the XLs could also be punishing ground attack aircraft. The XL had over twice the payload capacity of the standard Falcon, with almost a 50% increase in range. The bigger wing also meant for a much smoother ride at lower altitude. In late 1988, NASA proposed using the XLs for advanced supersonic airflow testing. They took over the aircraft in 1989. They were soon modified to demonstrate the benefits of something called laminar flow. To achieve laminar flow, the turbulent air on the surface of a wing must be removed. The XL was given a special wing-mounted fairing filled with millions of microscopic holes, each bored with a laser beam. NASA then added a vacuum pump to draw the disturbed layer of air inside the wing. This allowed the surface airflow to become smooth, or laminar. The benefit of laminar flow is less drag. The results of this experiment were dramatic. A plane that couldn't achieve supercruise before was suddenly capable of non-afterburning supersonic flight. NASA has recently upgraded the original XL in anticipation of follow-on testing of these high-lift and laminar flow experiments. These programs, part of the high-speed civilian transport program, should keep both of the XLs active with NASA well into the next century.